Okay, so
If not, we'll move to, yeah.
yeah, we can pass. I mean, the ball to Shawn Brown, who is the director of the Pittsburgh Supercomputing Center. So yeah, it's all yours.
Okay, great. I can share the screen?
Yeah, you should be able.
Gotta find the right window. Where did it go? It's the wrong presentation. Sorry, I'm working on 3 presentations at the same time. Okay, there we go. Now I'll share screen. Okay, are you able to see my slides?
Yep.
And it's not presenter mode?
It's okay.
Okay, that's good. Okay, so hi, my name's Shawn Brown. As Javier said, I'm the director of the Pittsburgh Supercomputing Center here at Carnegie Mellon University and the University of Pittsburgh. Been here for about a year now. I had the pleasure of working with Pradeep prior in Canada, where I was at McGill University working at the the McGill Center for Integrative Neuroscience with the C-Brain and Loris teams. But now I lead the Pittsburgh Supercomputing Center, which is a place that has about 60 people that have been dedicated to getting research done on high performance computing for a long time. I'm also the principal investigator on the Bridges 2 architecture, which I'll tell you a little bit about. Okay, so what the PSC has been focused on, we've been around for 33 years and been a leader in both and basically getting research done on high performance computing. So a lot of the stuff that Pradeep was telling you about, which was awesome, is what our bread and butter has been for a long time, figuring out how to field the latest and greatest in high performance and large scale computational technologies, and how to get the research done on those platforms. And so we've fielded over our 33 years, 21 HPC systems. HPC stands for high performance computing, 10 of which were the first or unique systems. So we've been in the habit of fielding serial number 0, as it were, kind of machines. In fact, the first machine when I was here about, 16 years ago, I'm old, was called Big Ben, and it was the first academic computer of a Cray XT3. It was a very unique machine. It didn't even have Linux on the nodes. It had this, back then they wanted to build these machines bigger and bigger. And so you had Linux on the machine, the services they had to be in time sync. Like if you wanted to run on 4,000 processors at the same time, the machine had to be very well time synced together. And so it had this thing called Catamount, which was basically a flat memory space. And so I spent most of my time removing system calls from software. It was good times. But it was a nice machine. But now we have a lot better, a lot more user-friendly machines I'll tell you about here in a little bit. So we're a national service provider for research and discovery. We're a part of the XSEED program, which is the NSF's Extreme Science and Engineering Discovery Environment. I'll tell you a little bit about that at the end and how you can get involved there. And most of our machines have been funded by the NSF. We've also had resources from the NIH and other funding agencies to field machines, but we generally put these up, and they're freely available to to researchers at any qualified U.S. institution. We also do research projects, so we both collaborate with a lot of people and also lead research projects. We right now have 30 active funded projects in or approximately 30 active projects at any given time. I'll tell you a little bit about some of those in a bit. We do a lot of education and training. So we lead the National XSEED Workshop program. We've been doing that for years. We do workshops on how to get involved in XSEED, big data and science, MPI, parallel programming, OpenMP, a number of different workshops that we hold yearly over, and they're all remote, have a big remote component as well. So we usually are training like 200-300 people at a time with those. And we're also getting involved in building curriculum at the university. So I'm talking with the University of Pittsburgh and CMU about building curriculum for science students to be able to do practical high performance computing. as basically that would imply that we're active members of the CMU and PIC communities, which is kind of why I'm here. Really happy that Pradeep has moved to Pittsburgh and invited me to come and talk to you today. We have a really good computational environment here, and some world-class research at both of the universities. We're also a network provider. We have a networking group that provides the Three Rocks network infrastructure, which is an infrastructure that works for that provides internet to many of the smaller universities and even larger universities around the region. And we also work with industry and have corporate partnerships and affiliations. In fact, our machines are generally some of the largest corporate affiliations out there because we work with a vendor directly to build these machines. And I'll tell you a little bit about some of those machines in a minute. So these are some of our current machines providing world-class computing. So we have the Bridges architecture. What Bridges was about, that's our largest machine. That is a machine that was designed from the get-go to be a heterogeneous supercomputer and connect new communities to advanced research computing. So rather than being sort of a monolithic one type of computing, it actually has several types of computing. It has GPUs, it has very large memory nodes, it has regular capacity computing and such. We even have a Hadoop Spark partition in it. That machine is nearing end of life. It was a partnership between Hewlett Packard Enterprises, Intel, NVIDIA, and ourselves. And there's some statistics there. This is the type of numbers that we support at the PSC. So we have like 2,100 projects. It's actually more like 2,700 now. I'm writing the final report for that machine, so I have to know. I know these numbers, but 18,000 users. And just across a wide array of different sciences, any scientific field you can think of, you name it, we've had it on there. Bridges AI was an addendum onto Bridges, which was intended to provide state-of-the-art GPU resources to the AI community. So that was our first